So I've been working on this. Some of the things I've done since I got it started. Finally got my XY calibrated. I was having a lot of problems with that. I noticed that when I surfaced the top, the X motor started to overheat, and as it would come back across, it would come up too soon. So the X was overheating. I got to figure out the potentiometer on the board, adjust that down, I guess, voltage, amperage. And try to put a little less pressure on me. It's the same motor as the size, but with two motors on the y-axis, I think it's using up the energy a little better. And I've got a totally different motor on my z-axis, and it doesn't seem to be having problems. So either I need to replace the X motor or adjust that potentiometer so it doesn't start to overheat. When it overheats, it's missing stuff, I think. When I do small jobs, it seems to be very good, hold true to what it's trying to do. I just cut out some cam locks. I don't like them. They're kind of cheesy and they're really thin, so I went with something different. Now I 3D print my cam locks, and these are really nice, and they lock in good. I don't have to make a couple of those. Actually got another one on the printer right now. These work out really good. I'm going to make about 8 of them just to have them laying around. And they let you do a very small lock all the way up to a very big lock, so you can get, 1.5 inches or right up against it, just about, so you move it that much over. And they're pretty tight once they're on there. If you get one on each side, or one on all 4 sides, it's really tight. If you really want to be tight, you could do 2 on the bottom and 2 on the top and sides. So I'll make 8 of them. So I can do 2 on every side. The bigger it is, the more you want to lock it in place. So I'll make 8 of these for now, at least. Start off. This worked out really well with the threaded rods I have in here. I went out and bought a 1-inch threaded rod with a nut. One that's threaded nut, I guess that'd be. And they fit right in here perfectly. They don't need to go in too far. They do start to pull up on it, but the thing of it is they can't pull up when they're pushing down. So they're pushing down. You just don't want them to go through. If they go through, they will start pushing on the bottom board, instead of lifting your whole board up. So you just want them really to grab in, and that's it, and then start tightening down, which is what I kind of have right here. So they're just a hair a bit taller than that. I've actually put a washer in there to make it for a little bit of space, so that I'm never pushing more down than what the size of the table is. I don't want it lifted, it's wasteboard up. Been doing really good about cutting these. When I tell it it's 1/4 inch and it's 1/4 inch wood, it doesn't cut through. I prefer it not to cut through too much. I don't want to destroy the wasteboard. I know it's going to get hit eventually with a little bit, but you don't want to go deep gouging into it, especially since my threaded nuts are only down about a 1/16 to an 1/8 inch in some places. Some places, the very back, they're actually touching. I'll show you a picture of where I have when I was surfacing it. I actually hit the thread nuts in the very back. So the back of this thing is much higher than the front of it is. That's the way it was built. So that's why you surface your wasteboard. What else? Oh, I'm adding vacuum lines. I'm using a standard shop vac with a Home Depot dust collection unit. I'm not sure what it was. Basically, it fits on the top of a, not much light back here, I apologize. Fits on the top of a 5-gallon Home Depot bucket. You plug it into your shop vac, and it's basically one of those tumbler things that circles the dust around and catches the dust before it goes into the shop vac. That way, when you clean out the shop vac, it doesn't clog up, that fine dust doesn't clog up your filter as fast. So we'll see. It seems to be working really good right now, but I haven't used it very much. I didn't use it for the surfacing, which probably would have filled it because there was so much dust from the surfacing, it was maddening. So I used just the shop vac for that, and it did clog up the filter. So we'll have to work on that. So that runs out the side here. I'm going to build a little wall going down this side and around this side over here to kind of, and on the top, to block that in, put a little foam on the outside of it, quiet that down, because that's one of the noisiest features of the piece. The other piece is obviously the Dremel, or in this case, trim router. I have an exhaust coming out here that I was going to let it run outside, but what I noticed was, when running like this, most of the noise now is coming from, about half of it's coming from here, and the other half is coming from there. So I need to find some kind of muffler. But I didn't want it to be all trapped inside of this box that I'm going to build, because I feel like that would just throw, whatever's going off the exhaust right back into the top right here, I don't know. I don't know if you have to have an exhaust outside of it or not. If you're sucking that much air into the box from outside, from external pipe, eventually that air has to go somewhere, and it can't just come back into this boxed area because you would create a pressure causing the seams to spread. And assume that that would be bad for it, so I have to exhaust it out the side. I don't know if my box is going to be that tight, but nonetheless, if I exhaust it out the side, then I also exhaust out all the sound over here. And I don't want to exhaust all the sound out. I want to capture that sound. So I need to build some kind of muffler system. I'm going to look that up online, see if there's some kind of muffler system I can build. Who knows, maybe some, run it through some foam tubes, like swimming pool tubes or something. That's all I can think of right now, so that's what I'm looking at. I don't know if I showed you this earlier in the video. I have a dust vacuum that I 3D printed. I'm not going to show you the download 3D print name, but maybe I can capture with some light the name of the AKERIC.com. I don't know who that is or what he does, but that's where I 3D printed this design from for here. Worked out really well. This piece here is plexiglass inside here, which you're supposed to be able to see through, but I really screwed it up. I'll end up popping it back out and redoing it because when I printed it, my calibration for my X and Y were wrong, and I had to adjust my steps, so it doesn't even fit in there properly. So I super glued it in. That didn't hold really well, so then I siliconed it in, and now it's got silicone all over it. You can't see through it. So, whatever. It works temporarily. It's a good vacuum. It actually is, when I ran these, no dust escaped at all. That's a pretty bold statement. Minimal dust escaped. But the noise is my big issue now. Can't run this during the day without, like, totally taking over the house. This is in the basement, right below our bedroom. So, you know, the noise travels upward. So now I need to isolate the noise from the vacuum and isolate the noise from the router. I don't think the machine's too noisy in itself. It's fine. It's really the noise from the router cutting and the vacuum that I need to isolate. So I'm going to do them in their own little fashion. So I'm going to start with the vacuum, isolate that noise, and then I think I'll build some kind of encapsulation around this entire table to encapsulate the noise of the table. I haven't decided how I'm going to do this. I'm going to do it on the top of the table, or down the sides of the table, around the whole table. I definitely will have to have some kind of plastic doors on the front so I can at least see in. And I need something that I can open and put my wood in. I do like the idea of being able to access things from the side of the table. So if I put walls here that are permanent walls, I will not be able to access the side of the table in this fashion. When it comes to tying things down, you got to be able to take these things and put them back here, or else all these holes back here are pointless. And if I put a wall here, then I have no way to get in there. I'm not going to crawl in there. So whatever I build wall-wise, I kind of was thinking, this is crazy, but I'm kind of thinking of a wall. I got a big I-beam up top here. Let me zoom up a little bit. I got a big I-beam up here. Nothing stopping me from tapping into this I-beam with two chains and having a hoist that raises and lowers an enclosure that just sits right above it. Doesn't need to be that tall. They can come down here and just sit on the table and then go back up when I'm not using it and then come back down. It's complicated. It's a lot more than what I wanted to do, but when thinking about it, it makes the most logical sense to me, because then I can access everything, and the enclosure is up above when I'm not using it for loading, setting up, and all that. And then I fire it up, I watch it start, a little noisy, and then I slowly lower the enclosure down. What that would entail me to have to do is take my vacuum and tap it into my enclosure, and then have the outside of the thing attached to the top of the enclosure, and let this go up and down with the enclosure. So this needs to be some kind of stretchy, open-close type vacuum, not this type. Which I have seen those, that as you pull on, they expand, and as you let them come back together, they collapse. That would probably work well, if I can find that type of pose. I don't know exactly where I landed on this side. I got a lot of equipment on this side, and didn't leave myself a lot of room. So I would definitely have to rearrange where my equipment all sits. Originally my goal was to run bolts through the table and run all the equipment underneath the table, keeping it away from the dust. So there's still enough wire here. And for the most part, when there's not, I have these little bus blocks over here on this side. I have these little bus blocks that I could definitely tie down everything, run it through a hole here, and then drop it through the table, as I did here. This is nice having it at the top, but it doesn't have to be here. It could be mounted on the front right here, out of the way. It could be mounted just about anywhere. It's just wires. I could always extend any wires. So that whole side would have to be cleaned up in some fashion. Plus, my makeshift breadboard here for my end stops has to be redone. But I haven't done that yet because I'm still thinking about if I want to upgrade to Gerbil 1.1, and if I do, that changes a little bit of it. So if it changes, I want to be able to have it to where I can change it without having to, you know, rewire it on, or make a new board or something. So that's where I am with that. In the end, I think I'm getting close. I've actually gotten some clean cuts. These were nice. I need to sand off the tabs. The tabs are kind of annoying. That's why I like that tape down method. So with tape and glue. So, but of course my glue is now almost out. I've been using that a lot lately. I don't have a Z-probe of any kind. I've been using the touchdown and paper. You know, you slide the paper under a bit and you pull it back and forth until it's perfect. That works okay, except when you have a dust guard on there. Then it doesn't work so well. So I need to invent some type of touchdown Z-probe method so I can place it in there, let it come down, touch, and I know exactly where I'm at. So I'm going to work on getting that attached. This carriage has a spot for a plug-in for the Z-probe, but I haven't thought it through completely yet. I'd have to run complete another wire through here. I don't have a wire that goes to that. And these are a little tight. I'm a little concerned that they're too tight, and they're causing some stiffness, which could be part of why I'm having trouble, but it doesn't seem real stiff, just a little stiff. My wheels are pretty loose. I mean, you can see this, I don't know if you can see it in the video. I'm probably standing right in front of it. But the wheel on this one is really loose, and that could be tightened, obviously. And the back one is really tight, so that could be tightened. And that's really tight, and that one's loose. I can spin that one. So that one I can't spin at all. So this one and this one are super tight, which, I mean, you want that tightness for it to grab as it's moving. I don't know, it could be that could be the drag on this one could be too tight between these two, and you just turn that a little looser so it's got more freedom to move. Because this and this don't feel the same. This is tighter going this way than that is going that way. And there's two motors on there kind of drawing an amperage when I pull this way. It's got two motors drawing some kind of amperage, but I don't know how that whole thing works. They're not tied into anything, they're not turned on, so there should be no drag. This one's got more drag, definitely. We'll have to see if maybe adjusting those a little bit will help with my XYs. So that's where we're at right now. We'll be working on noise reduction as soon as I get this hose connected together. Right now I'm 3D printing a hose connector, which obviously I'll have to re-3D print if I have a drop down. Anyways, that's all for now.